Hey everybody, this is Larry, this is me going with Q2 of the weekly contest 490 check Digitorial permutation. Hit the like button and subscribe button, join me on Discord, let me know what you think about this one. So there are a lot of things about this one, and I think it can definitely read as very tricky, but this is a good exercise in kind of breaking the problems into different components, right? Okay, so one is, well, we have to find out how to figure out the factorials of the digits, which means that we have to figure out the digits. Yeah, so we have to break a number down to its digits, right? Step one. Step two, calculate the factorials, have a function or whatever. Step three, and it only goes up to 9 factorials, so straightforward. It's just sum it up, right? So this is a very dense, like, 3-step thing already, right? But you have to figure out how to component. You have to figure it out, right? And then it's just you go to the number itself, which is an if statement. It's fine. You can maybe say it's a component. And then now the additional trick, because if it was just this, then I think you probably just crank it out pretty quickly. But then there's the permutation part. Well, and this is another component. It's just checking out whether two numbers, or maybe you could say one number, a permutation of one number is equal to another number. And this is what I don't know how long I talk, about a minute, but this is basically a component that, if you want to call it that, if you have a lot of practice, you just see it in places, which means that, well, if a number is equal to a number is a permutation of another number if all the digits match and the frequency of the match, and that's basically the idea. And once you do that, then yeah, once you break it down, then you're able to solve this very quickly. This is basically my code. I convert it to a string because this is how I get the digits by digits here. I set up the total, so we get the factorial in Python. There's already a library, thankfully. Convert it to int from the string, and we just sum it up. And this is how we do this part, right? And then now the permutation part, we just, like as I said, you only need to count the frequency. So here we count the frequency of the digits of the total, and we count it as the input, and then we just return whether they're equal to each other, the frequency of each one. Then you can permutate them however you like, and that's it. And maybe getting rid of leading zeros if that is applicable. I don't know if that is, but n is not going to be, like, s is not going to have a leading zero, so it shouldn't matter, right? There's also another way to do this, of course, is if you sort the digits, though maybe you might run into leading digits there, but maybe not. But yeah, that's it. That's all I have for this one. What's the complexity, right? I mean, you could say, I mean, this looks very funky. But you could also just say that this is constant, right? Because you have 9, it only up to 9 factorial. You have 10 numbers. This is fine, right? This is O of 1 if you cache it. And because, this is O of n, not this n, but n in the number of bits. So this is going to be linear. This is going to be linear. And then the combination, not combination, but the comparison is going to be linear. And that's it. I mean, it's actually better than linear because it's just a number of unique. It is bounded by both the digits and also the number of things in the alphabet, right? And by alphabet, I mean in this case from 0 to 9 number of digits. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. Or English is hard, maybe. Come on, please, no wrong answer. Well, you usually have a wrong answer on that one, I feel like. Especially the way I'm going at it. Okay. Digitorial, the sum of the factor. Okay, is that it? Yeah, okay. I mean. Oh, wait, permutation. Okay, no, I mean, that's still fine, right? You could probably cache this, but I am too lazy. Okay, so then now we want n, right? So okay, so then we also want string of total collections.camera, something like this. F1 is F2 is the same thing, but we have string of S is already a string, return F1 is equal to F2, something like that, right? True, false, I mean, not enough confidence. Okay, well, that's fine then. It was a little bit YOLO. I probably should have tested a little bit more, but I'm glad it worked out. Okay, maximum. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest, this problem, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.